Alright, so today guys, we are going to continue with residuals, okay? So remember in the last video we started talking about it, today we're going to be continuing on with it. So, residuals are defined as the vertical distance between the regression line and the actual data value, okay? If you remember, I drew up the scatter plot and we had our regression line and then we had the arrows to each data value, okay? That was a residual, now we've just got a bit of a definition for it, okay? We're also going to be looking at residual plots. Okay, so a residual plot is a graph of residuals on the y-axis against the explanatory variable on the x-axis. Okay, hopefully that's pretty straightforward. We will look at this in a little bit. First, we're going to look at actually how to calculate a residual. Okay, so right here we've got the formula for a residual value equals the actual data value take the predicted data value. Okay. So that's what we're going to be using for this example. As you can see, we've got here, so we've got the actual price of a 6-year-old car is $6,500, okay? Calculate the residual when its price is predicted from the equation below, okay? So what we've got here, and I've already underlined it for us, is we've got the actual price of a 6-year-old car, $6,500, so that's my actual data value. Calculate its price when it is predicted from this formula. Okay, so I can figure out its predicted value from using the following formula. I can put it in to calculate my residual value. Okay, we're going to go through this one really quickly. It's pretty straightforward. I'm talking in this question, the actual price of a 6-year-old car is $6,500. Okay, the big thing here is in the equation we need to know the age, and we've been given the age. Okay. So I can write my price or predicted price will be 35,100. Take 3,900 multiplied by 6. Okay, I've just multiplied that by 6 because the age of the car is 6. That's why it's pretty straightforward for that one. When I put that in my calculator, I get 11,460. Okay, now I know what my predicted price is, I can go through and I can calculate my residual. Okay, so when I do this, again, very straightforward. The residual equals the actual take the predicted. Okay. Now it's just a matter of substituting in what was my actual value, 6,500. What was my predicted, 11,460. Again, put that in your calculator and we get negative 4,960. Okay, so that residual is negative 4,960. The big thing that you will notice is that it's a negative. Okay, residuals, they can be negative, neutral, or positive. Okay, it's really where it sits on that line, and that's what we're going to go through next. Okay, so the residual for this question and this bit of data would be negative 4,960. Okay, now we're going to look at actually interpreting a residual plot. Okay, to start with, I've got two different examples, top one and bottom one. Okay, first one we're looking through is the scatter plot here. Okay, we've got the scatter plot. Just a normal scatter plot I've generated with my dots and my regression line in it. Okay, this we've already touched on a lot. I've just done a real rough one. You would definitely be using graph paper for this. Remember, we've got a whole bunch in the classrooms if you need. So this is our first scatter plot. Okay, what we've got here is our residual plot. Remember, our residual plot is a graph of residuals on the y-axis against the explanatory variable. Okay, what that means is my residual value is going to be up and down here. Okay, so in this previous question over here, my residual was negative 4,000. Obviously, my graph would be a different scale and it would be at close to negative 5,000. Okay, what I've done here, and as you can sort of see, this purplish bluish line is represented here. Okay, so we've got one above, one below, one above, one below. As you can see, it follows that trend and it will match up. Obviously mine, I've just quickly done it so it won't match up perfectly, but the ones in your textbook will. Okay, the main part of this is just understanding how to read this residual, okay, which we'll go to in a second. We just want to make sure that you can at least understand a little bit of how the scatter plot gets to a residual plot. Okay, so again, just to reinforce, my residual value is on the y-axis, then my explanatory is on the x. Okay, so as you can see, it's still kept that same. The next example down is, well, this one's linear, this one down here, it's not linear. Okay, we can see a bit of a curve in it, therefore it is not linear. Okay, again, I'm going to do the same thing, but one thing you will notice is, remember, when I'm looking at residuals, is it negative? Well, is it below that line? I've got a massive gap where there is no negatives. Okay, when we come over to here, you can see there is that same gap where there is no negative, it is all positive. Okay, the starts and ends are negative heavy, starts and end here are negative heavy. Okay, that's what we're looking at, that's graph, and then we're going to look at actually reading this. Okay, so when we go through and we're looking at our residual plots, we need to go and we're going to try and read these. Okay, when we first look at this, all the dots here, it just seems random. Okay, there's no curve, there's no nothing, it is just a random plot of data. Okay, so we start by writing that down. Okay, residuals are random, therefore linearity assumption is met. Okay, so all that's saying is the linearity assumption is met, meaning that it is linear. Okay, so when we've got a random residual plot, it is linear. When we look down at this second example, we've got, it's not random, we can see a curve in this residual plot. So we write residuals are curved, therefore, and the same thing, the linearity assumption, but this time it will not be met purely because it's not linear, they're not random. Okay, so the linear assumption is not met. Okay, so this is just nice and easy. We're just looking at when they're random, they are linear, and we can see that by the two. When we look at and it's got a clear curve, well, no, they're not linear. Okay, so that's all a nice quick one just to go through the basis of this. Start working through the textbook questions. If you need any help, obviously come and see one of us teachers.